Thanks, guys. Welcome. So, I'm here to talk about incident response and resolution in the new world that we live in, the world of DevOps. I'm sure you guys have heard a lot about DevOps. You might be on a DevOps transformation yourselves, or you might be a DevOps native where you started in your company where it's very mature, very operationally mature. Just before I jump in, I'm just curious, how many of you have heard of PagerDuty already? All right, got some hands in the audience. Maybe some of you are on call right now. Sorry? How many of you heard of PagerDuty? There you go. Cool. So for this talk, I'm going to try something a little bit different. So what we did in order to kind of talk about incident response and resolution best practices is I took a real incident from PagerDuty's own history, and I will go through the entire timeline for that incident, and we'll look at the different roles, and we'll look at the best practices and how we handle incident response and resolution at PagerDuty, and hopefully you'll have some learnings to take away from that. So, like I said, this is a true story. The events in this presentation actually took place in San Francisco and Toronto in January, and in the interest of brevity, some details have been omitted. So, the services involved. There are two, so we have a microservices architecture, and these are two of our microservices, Web to Kafka and Incident Log Entry Service. These run on top of Docker, and then we use Mesos and Marathon for scheduling and orchestration of the Docker containers, and these run on top of Linux. And just a quick description on the services. So our architecture started out as a monolith. The main monolith is a Rails app called Web, and then over the past 4 years or so, we've been breaking up that monolith, but we still have some of it left, so we still have some work to do. So this Web to Kafka service is actually responsible for observing changes that happen in Web, which is the monolith, and then publishing those out to Kafka for other microservices to consume. And then the Incident Log Entry Service, if you use PagerDuty, this will look familiar. This is an incident, and each incident has a set of actions that happen to it. Like it was triggered at this time, it was assigned to this person, it was escalated, et cetera, et cetera. Those are all the log entries that the ILE service is responsible for. Let's also look at the people. So in terms of the major incident response, we have a few key roles. Eric is our incident commander. Ken is our deputy, Peter's the scribe, and Luke is the communications liaison. And I'll talk a lot more about what these roles entail as I go on. And then we also have a whole set of subject matter experts. So you can see there we have David and Case who are on our core engineering team. So these guys are responsible for services that other engineering teams consume, such as Web to Kafka. We have Evan, SRE on call. Renee is IM people. That's the team responsible for the services that deliver notifications. Zaina is mobile, JD's IM data, so that's the ILE service, the Incident Log Entry Service is part of their purview. And then Priyam's event management, which is the services that are responsible for ingesting events and processing them. So jumping right into the incident. So the first thing that we do, what happened here, actually, just to back up for a second. So what I'm going to do next is I'm going to go through the actual chat timeline. So when we have a major incident, we actually use our chat, we set up a war room inside of our chat. And this is the actual timeline taken out of our chat. So what happens first is David enters the command IC page, which kicks off the incident management process. And we also have a chat bot that sits within that chat room and responds to these commands. So this is a command to the bot. So what the bot does is it starts paging a few different people. So it pages Eric, Ken, and Peter. Eric is the incident command primary. Ken is the secondary, and Peter is actually shadowing, so he's training to become an incident commander. So he's there to observe and see what's going on. And what happens is the bot kicks off the incident, it creates an incident in PagerDuty. So next, David talks about Web to Kafka is down, and he's not sure what's going on, so he needs help. Eric comes in, and he says that my mic fell off. I'm going to talk like this. So basically, Eric comes in and says he's taking the IC role, which is the incident commander role. So what is the incident commander? So this is the wartime general. It's the main decision maker when an incident is happening. And the goal of that individual is to drive the incident to completion as quickly and effectively as possible in order to minimize customer impact. So that entails gathering data, so asking subject matter experts to diagnose and debug the system and see what's going on and understand what's the root cause. It's about listening to the subject matter experts and collecting proposed, sure, take a second here to adjust. I need a backup mic just in case, but it's okay. I'll make it work. Okay. Yeah. So, like I said, listening and collecting proposed repair actions from the subject matter experts, making quick decisions on the fly. So deciding, what are we going to do next? How are we going to resolve this problem? What should we try? What should we do to resolve or to debug or to kind of progress in resolving the incident? And then acting. So this is about making decisions quickly and then delegating those decisions to the subject matter experts to execute on. The incident commander should not be going in themselves and logging into systems and running commands and debugging. They should be leveraging the team and the subject matter experts that are working with him or her. So going back to the incident, Ken, who is actually the deputy, so he's the incident command backup, is looping in Renee to join the call as well. So Ken is taking on that deputy role. Evan's jumping in as well. He's saying, hey, I'm here, I'm on call, let me know if you need me. Priyam is also jumping in. So you can see that we have a couple of folks here who are jumping in from 2 different teams, and Ken is taking on that deputy role. So what is the deputy exactly? This is the backup incident commander. It's essentially the sidekick, the right-hand person for the incident commander. And they're responsible for monitoring the status of the incident, for being prepared to page other people. So you saw that Ken, in that case, looped in Renee. And they're also responsible for providing status updates to stakeholders in the business. And this is actually a really important part of the job. The reason for which is that sometimes, for an incident, you have a group of people that are responsible for solving the problem, and then you also have other people in the business that kind of want to know or need to know what's going on. So even to the point where the CEO, if there's a major customer impacting incident, they're going to want to know, hey, what's going on here? What's the impact? When are we going to fix this thing? And what you don't want is for folks like executives to jump in on the incident call where a whole bunch of engineers are working together and trying to solve the problem and start asking questions and derailing the conversation. You want the engineers focused on solving the problem, and you want to keep the executives in the loop. But you don't want to mix the two because then that derails the engineers. So this is why this role is really important, because they provide regular updates to the stakeholders, generally in the format of, here's the problem, here's the impact, we have people on it, so rest assured we got this covered, and here's the customer impact, and the next update is coming in 10 minutes. That kind of thing is a really good practice. So going back into the incident here, you can see that Ken is actually documenting what's going on right in the chat room. So he's asking David, what have you looked at? And by the way, we have the chat room, and then we also have a voice call. So we have a conference call. Everyone's in on the conference call because that's a lot more higher bandwidth. It's a lot faster to actually talk and make decisions on the fly rather than typing it in chat. Chat is more of the record keeper. So, and then David says that he's been looking at logs. He tried restarting the boxes, but it didn't help. And Ken at this point is both the deputy and the scribe being the note taker. Zaina jumps in and says that she's seeing a lot of crashes in the Android app around the incident log entries. JD jumps in saying no ILEs are generated because that service is down because it's not able to query web to Kafka. And this is, folks, Renee as well, talking about how notifications are actually still going out. So PagerDuty is still paging people properly. Now, these folks are discussing the customer impact right now. And then Peter jumps in as well. He says he's the shadow, and he takes on the scribe role, and then starts taking the notes and takes that role away from Ken, who's already doing the deputy role. So he starts documenting that Eric is looking to find Mesos experts and looking for logs and dashboards. So you can see that. Now, what is the scribe exactly? So this is the record keeper for the incident. They're responsible for adding notes to the chat room that are important and that need to be kept in the record. So essentially, a log of what are we trying to do, what are the debugging actions, what are the decisions we're making, and what are the remediation actions that we're taking. This is actually really important for the post-mortem after the incident. And it's also important for new folks. So let's say you loop in a new individual into the incident, and they want to know what's going on. They're brand new. They don't have the context. Well, if it's all in the chat, they can catch up quickly. They're also responsible for adding to-dos to the room that indicate follow-up items to be done later. So remember, when you're working one of these incidents, it's really important to put out the fire immediately. You don't have to necessarily worry about longer-term remediation actions or longer-term things. You want to put out the fire fast, let the dust settle, and then figure out the long-term kind of root cause resolution later. So this is what to-dos are for, to remember those things for later. And then also monitoring tasks that the IC assigns to other folks. So on the call, the incident commander is going to ask, one person to do this, and another person to do this, and another person to do this, and then come back to me in a few minutes with the answer. And it's easy to lose track of all of those actions that are supposed to happen. So this is another job for the Scribe, is to record all those things, and then to actually remind the IC, hey, make sure you follow up with this person, or so that you don't forget that these things are happening. So going back to the incident here, you can see that Eric is asking, what is the customer impact? And then Peter's documenting, David is saying no ILEs can be created, and no incident details are being, so there's an error message in the UI when you try to expand to see what the details for the incident are. Then Peter jumps in as well, and he says, he's documenting, and Eric is asking, is there a communications representative on the phone? That's Luke. And then Eric asks Luke, please compose a tweet. So this is actually part of our process. When we have a customer impacting issue, we actually send it out via our Twitter channel so that our customers know, hey, our service is impacted, it's degraded, it's down, whatever it may be. So here Luke comes in and he suggests a tweet. There's an issue affecting incident log entries component of the web applications, and we're investigating it. And then Luke to tweet, and the message is sent out to customers. We also use statuspage.io to send these updates too. So they actually go out via Twitter and status page. So you saw there that we had a communications liaison. So what is this person? What does this role entail? This is the link to the customer. So they're responsible for monitoring the customer and business impact of the incident. And they're responsible for providing regular updates to customers. So you've seen that we send out that tweet and that update on the status page. So going back to the incident here, you can see that right now David is trying to add case to the incident. Yeah, that's how you actually pronounce that name, case. He's Dutch. And Eric is asking, is there a runbook for Mesos? Because Mesos is actually a pretty new service at PagerDuty. And we don't have deep expertise, or at least didn't have deep expertise back in January, and Case is actually the expert on Mesos. And apparently there is a runbook, but it doesn't cover this particular issue. So as part of this, we paged the Case, who's the Mesos expert, who is not actually on call, because we're going to do whatever it takes to resolve this problem. Then you can see that Peter actually recorded a to-do. Let's create a runbook later for Mesos so that, to make sure that this type of problem is covered. So you can see that. And then Case comes onto the chat. He says he's away from laptops. Remember, he's not on call. And he just arrived at a pub for dinner. And he's on the East Coast as well. He's based in Toronto, so it's 6:30 in his time zone. So he joins the chat there. And then Eric asks him to come in on the bridge because they have a bunch of Mesos questions. And then the next update here is a lot of stuff. So Evan is saying that the system, some of the servers involved are actually completely hard down. They're completely unreachable. Slave 1 is up, slave 2 is unreachable, slave 3 is unreachable. We have 3 slaves, so that's how we run that system. And only 1 host is up. And then he's also saying that he's seeing some memory exhaustion type problems. So up next, the incident keeps progressing, and we see that we only have 3 slaves in the cluster. And we actually have another this cluster is running on US East, US West 2, and we actually have an entirely new cluster running on US West 1. So we have a way, like we have another cluster that we can, as a backup, essentially. So we have two options here, to kick more slaves or actually restart the Marathon orchestration service. And then Evan comes in saying, OOM killer, this is out-of-memory killer, it's a Linux process, is actually kicking in on slave 01. So this is actually pretty important, remember that. So what that means is a process is taking up too much memory, it's only allotted a certain amount of memory, it goes over that amount, and OOM killer comes in and kills it off. So Case is suggesting let's restart the slaves first before we do anything crazy. So Eric tells Evan, please reboot slave 02 and slave 03. Evan's noticing that slave 01 is now hard down. That was the one that was still up. So you can see that we're having these servers keep going down and we don't know what's going on. And then here, David is asking the question of, should we actually bring up another cluster? So do that data center flip from US West 2 to US West 1, which is actually a pretty big deal, right? We haven't, I mean, to tell you the truth, we haven't tested that scenario of flipping data centers, and now we're considering it in the heat of this incident. And Case is actually, as you can see, pretty optimistic about it. He thinks it's very doable, even though we've never done it before. So Eric's actually suggesting to stop the slaves in West 2 and restart them in West 1. When Evan notices that slave 02 is alive, and then they decide, okay, hold on, let's not do this data center flip just yet. Let's wait 2 minutes and see what happens, right? So what happens? This thing keeps falling off. Excuse me. So what happens next is we notice that slave 02 is quiet and it's starting to, it's trying to start, but it's exiting with code 137. And that's actually pretty important because 137 means that it's being killed by OOM. So OOM is killing Docker containers continuously, as you can see there. So they finally realized the actual problem, that OOM killer's killing the Docker containers over and over and over. So they start up, they run out of memory, and OOM killer is killing them off. So the proposed action in this case, the proposed remediation action is to actually configure Marathon to allow these processes to have more memory. So, and then also to reboot slave 01. So the resolution action, as I said, is to increase the memory of the Docker processes from 512 megs to 2 gigs, which is a big increase. Now we're asking about what is the customer impact, how many tickets are we seeing, because the service has degraded performance. Well, there's 4 tickets and 2 customers chatting, so 6 tickets in total. So that's an update coming in from that customer liaison. And then finally, we take those remediation actions, web to Kafka is back up, things are running, and notifications are running fine, and finally the log entry service is seeing some progress. So the incident or the system is starting to recover. So the punchline, let me tell you the actual root cause all the way through. So we had an increase in traffic, which caused web to Kafka to increase its memory usage. This caused the Linux OOM killer to kill the process. Then Mesos Marathon immediately restarted it, and then it ramped up memory again, and it got killed, and it got into this kill restart cycle. And this is the interesting part. After doing this restart kill cycle many, many times, we hit a race condition in Linux. And then that caused the actual host to go hard down. So that's why we were seeing those hosts that kept going down over and over and over. And then, of course, because there were other services running on the host via Mesos and Marathon, there were other services impacted as a side effect. So pretty interesting cascading type failure incident. And throughout that process, we've seen some of the different roles that we have as part of our incident resolution and incident response. Here are the different roles. So there's the incident command. This is the most important role in the incident. It's the person who's like the expert, who's the decision maker, who's the general. I don't recommend that you take on this role when you don't have a lot of experience with the systems. It requires a little bit of lay of the land, a little bit of, or more than a little bit of experience of running incidents and being on incidents before. So it's a big role and it's very stressful. The next one is the deputy. This is the right-hand person for the incident commander. They're responsible for monitoring the severity of the incident and the status of the incident. They're responsible for providing business and executive stakeholder updates, allowing the technical team to focus on the incident resolution. And if you have a long-running incident, like one that lasts for hours, you can actually, because it's such a stressful role, these two, they can actually swap. So the deputy can take over the incident command after a while. And then, of course, you have the scribe. This is the person that's documenting the incident, tracking follow-ups, tracking to-dos. So, for example, if the incident commander is asking someone, hey, do this and report back in 5 minutes, the scribe should track that and remind people, hey, did this actually happen? And then we have the communications liaison, who's responsible for the customer impact and for communicating to customers what that impact is. So you saw the tweet, statuspage.io, that kind of thing. And then what's not on the slide is all of the subject matter experts, all of the folks that are on various teams, owning multiple services, who are the experts on their service, and who are helping actually drive the debugging, the resolution forward. So I also wanted to talk about what happens after the incident is resolved, the post-mortem. And I love this stock photo of these guys smiling around the corpse. But I'll tell you how we do our post-mortem process at PagerDuty. So number one is about picking an owner for the post-mortem. So in this case, David, who was the initial responder, was the owner. We recommend picking one owner, but this person can leverage other resources in that process. Number two, scheduling the post-mortem meeting. So this was scheduled a few days later. The incident happened on Jan 6, which was a Friday, and it was scheduled for Jan 11. I recommend a fast turnaround, so actually putting an SLA on your post-mortems because they're fresh in people's minds. You don't forget what happened. Number three, creating a draft of the post-mortem report, conducting the actual meeting, and then finalizing the post-mortem report based on the discussion in the meeting. So what's included in a post-mortem report? Number one, a description of what happened with the timeline of events. And we've actually run through some of that in the chat room directly. What was the customer and business impact? That's important. What was the root cause or contributing factors for the incident? A lot of times these incidents don't have a single smoking gun or root cause. They can be caused by multiple factors. In this case, you saw that it was multiple cascading failures that caused this problem to happen. How we actually resolved the incident, so what did you do to remediate the problem and put the fire out? We also do this, which is a what went well and what didn't go so well, because postmortems for us are about continuous learning. So from the items of what didn't go well, there are learnings. And then I would say this is very, very important, the action items. What are we going to do to ensure that this kind of problem ideally doesn't happen again? And the first four things are components that are written by the owner ahead of the meeting, and then the last two are discussed during the meeting and kind of agreed upon by the team. So going really quick through the timeline, I'm not going to go through the whole thing, but you can see that it took us 7 minutes to actually detect the problem from the first time the systems noticed it. The time to acknowledge was really fast. David tried to get help from a secondary and from case before the incident was escalated. Then they escalated it, so David escalated it to Sev2 within 23 minutes, and this is when we send out that tweet to customers. Then, timeline continued, the issue is diagnosed here, that OOM killer restarted killing the Docker processes, remediation actions are taken, and the issue is recovered, and it's fully recovered. And then finally, we send out a tweet saying, hey, we're back up, the degraded performance problem is resolved. As part of the postmortem, we actually capture log lines or log files that are relevant, graphs, charts, anything that's relevant as part of that debugging process, especially when you have time to do it afterwards. That's the log line of OOM killer killing Docker, actually. And then looking at what happened, root cause resolution. I'll go through this quickly. So what happened, that's actually what we capture in our own systems. The root cause, as we discussed, is determined an increase in traffic, which caused Web to Kafka to run out of memory. OOM killer killed it. It got into this kill restart loop. And then Linux bug triggered, which took down the host's hard down. And the resolution was to increase the memory limit temporarily from 512 to 2 gigs, which actually put out the immediate fire. The impact, so going through this quickly, we spent 1 hour and 9 minutes in Sev2, so that degraded performance. We spent 0 minutes in Sev1, so that's good. We had 0 notifications delivered out of SLA, so this problem did not affect our notification delivery. We had about 1% of customers experiencing 500s on the incident details page, so this is when you're looking at an incident and trying to expand the details. 2% of customers experienced an error message on the /incidents page when you click that show details link. And then 1% of customers experienced errors in the Android app, and 8 support requests that were filed at the end of the whole issue. So let's look at the post-mortem meeting. So the goal of this is shared learning. This actually provides that learning feedback loop, which is so important as part of your incident lifecycle. And it can lead to improvements in a variety of different areas. So technical improvements are kind of the obvious thing, like what can we do better? Can we fix some bugs? Can we clean up some technical debt? Improvements in tooling, so maybe better CI/CD, better testing, things like that. There's also people improvements, so what I'm talking about there is training and knowledge sharing, and of course process improvements. So for example, if you have an on-call process where you don't have a backup secondary on-call, that's something that you'd want to look at. So looking at the post-mortem meeting agenda itself, number 1 is going through the timeline, ensuring everyone agrees that the timeline is comprehensive and accurate, and talking about what the group has learned by going through the timeline. So this can be, it doesn't have to be limited to action items, but the action items will come out of this process. So it's run in a kind of brainstorming type format. And then what you want to do is you want to talk about what went well and what didn't go well and capture that as part of the report, and then create the list of action items. So for us, what went well, what didn't go well? Well, the non-on-call core team members were able to help, so that was case. The SRE on calls were very helpful in debugging and identifying issues and restarting boxes, and notifications still went out, so it wasn't the Sev1 type situation. Of course, problems here. Core primary on call was unsure about when to escalate the problem to a Sev2. We didn't have a proper SLA there, which is a problem. The failing Web to Kafka problem actually caused cascading failures in other applications because those boxes had more than one service running on them due to Mesos scheduling. And then various UI components on the Android app did not handle missing the log entries well. So they ended up 500ing instead of having a degraded performance type behavior. So looking at the action items here, what are those? So action items need to be specific, measurable, achievable, relevant, and time-bound. So, don't set giant year-long things because that's not really wise. One really important thing is do not boil the ocean. Like, we've done this ourselves a few years ago where we made this mistake and we came up with a giant laundry list of everything we could think of coming out of a post-mortem. And then you come up with 40, 50 things, and you don't have the bandwidth to do all of those things. You have to think, what are the critical, most important things that you want to do here that are actually achievable? Because you don't want to stop all of your development and all of your feature development in order to fix every single conceivable problem here. You should try to create a variety of action items. So I mentioned tech improvements to production systems, technical debt, fixing bugs, things like that. Tooling improvements, so monitoring, deploy, testing, things like that. Process improvements, so making sure you always have a second level on-call person, making sure that you have a service operation guide and you have proper well-defined SLAs. Those are examples. And then improvements in knowledge sharing. So making sure that your documentation is up to date. I mean, we all know that docs a lot of time are not up to date, or that's a big problem, or there's no runbook there, so when someone's newer on the team, they don't know what to do because there's no documentation. Another thing that we do is we do on-call shadowing. So for a new person on the team, they should shadow a more experienced person. So looking quickly at the action items, I'm not going to go through these, but you can see that we actually did most of them. We still have one open item. This is a current view of all the action items from January. That one's probably not going to ever get done, but that's pretty good. And I also wanted to make a note about blameless post-mortems, because this is an important one. The quote I like is, you can't fire your way to reliability. So the problem with blameful post-mortems is that, I'll give you an example here. An engineer does something that results in an outage. If management then starts blaming that engineer and pointing fingers and shouting and reprimanding and et cetera, then that results in reduced trust between engineering and management. That means that engineers are afraid to speak up and they're covering their ass, and They don't speak to management, and they don't speak to each other either. So management is less informed on how work gets done, and engineers become less educated, and they don't talk to each other. And then what happens is errors and outages become more likely, and you end up with this virtuous cycle that's really, really bad. And this results in conservatism, so it reduces your velocity. It results in a lack of transparency, in more failures, and then ultimately what's going to happen is your best engineers are going to leave. They're going to go somewhere else, to a company that has a good development culture versus a blameful culture. So real quick, the public post-mortem. So this is actually available on our status page. You can actually look at it, and this incident happened on January 6th. So the idea here is you want to create a higher level version of the post-mortem for public consumption, because the public's not going to understand all of your technical services and all the intricacies of your architecture. So 3 sections for us: summary, what happened, and what are we doing about this to ensure it doesn't happen again. And then I would suggest you also apologize in a sincere way, because you let your customers down, they experienced a failure or degraded performance in your system. The last thing I wanted to talk about is the tools that we use. And I put together a slide of what we consider as best of breed tools in terms of incident response and resolution. And these are the ones that we prefer. It doesn't mean that they're the only possible tools, but it's kind of what we think are best of breed. So what we do is we use for metrics and monitoring Datadog. For logs, we use Splunk. There's other alternatives like Sumo Logic. For application performance monitoring, we use New Relic. And for error reporting, we use Bugsnag for our web app, and we use Crashlytics for our mobile app. And these all feed into PagerDuty. So our tool and our platform does alert triage. So all of these events come in, and we triage, we reduce the noise, we group, we cluster, we do all that stuff. We do the alert and incident response. We do the collaboration around incidents with the chat room and with the conference calling. And then we also do the incident communication. So letting the stakeholders know, sending out stakeholder updates, that's all handled through our tool. For runbooks, we actually store all of our runbooks in Confluence. Collaboration, HipChat, and BlueJeans are great tools to use. For customer communications, we use StatusPage to post public updates to our customers, and we also send them out on Twitter. And then finally, this is a new tool that we built, which is in beta right now. It's a post-mortem automation tool. So what it does is it groups together the entire timeline of the incident, and it helps you guide you through that post-mortem process, and then it lets you collaborate on creating the report and then publishing it out. And then this will integrate with Jira for those follow-up action items, and that's what we use for our project management, our bug tracking, our issue tracking. And that's all I have. Oh, one more thing. So we've actually open sourced and published all of our incident response process and training. It's available at response.pagerduty.com. It's actually on GitHub, so we're accepting pull requests if you guys have any feedback or suggestions. So please check that out. And that's it. Thank you.